Picture a cosmic orchestra composed of countless stars, planets, and moons, all producing a symphony in flawless coordination. Yet there's one part of this celestial music that has puzzled astronomers for centuries: exoplanets. Exoplanets are natural planets located beyond our solar system, tucked away within the vast expanse of the Milky Way. Among the enormous variety of cosmic bodies, it may surprise you to know that some exoplanets are so remarkably similar to Earth, so closely resembling our own planet, that they could be seen as its twin in the heavens. Let's explore the captivating world of Proxima B, just a mere 4.22 light-years away. The James Webb Space Telescope is revolutionizing our understanding of these cosmic wonders, pushing the boundaries of exploration and providing us with new insights about these distant celestial beings. Imagine your thoughts drifting through the expansive reaches of our galaxy, the Milky Way, home to an astonishing number of exoplanets. In fact, there are so many that their total number could be in the quintillions, far beyond human comprehension. To put this into perspective, if each exoplanet were the size of a grain of sand, they would not only fill the Grand Canyon, but we could construct an entirely new geological wonder on Earth, an expansive Grand Canyon 2.0 stretching for miles. The most striking fact is that about 20% of these planets are considered to be Earth-like, showing similarities in geological makeup and atmospheric composition. This means that there is a 1 in 5 chance of discovering a planet that could resemble our own. But the story doesn't end there. Alongside these planets, there could be another quadrillion moons, rocky satellites similar to our own moon, engaging in intricate gravitational dances with their parent planets. With so many possibilities in the vast cosmos, the prospect of finding a world that could harbor life becomes more tantalizing with each discovery. Having unfolded the immense scale of the universe, it's time to introduce the ultimate tool to explore it, the James Webb Space Telescope. This celestial detective, often likened to a space-age Sherlock Holmes, uses its massive 6.5-meter primary mirror, 2.7 times the size of Hubble's, to capture details from distant stars billions of light-years away. The telescope's unprecedented ability to observe and analyze celestial objects allows it to detect the faintest light and reveal intricate details of orbiting planets. What sets the James Webb Space Telescope apart is its technological sophistication, including advanced sensors and spectrographs. These tools go far beyond just observing objects in space. They can decipher the unique light patterns emitted or reflected by these celestial bodies, offering information about their atmospheric conditions, composition, density, and even their mass. Essentially, it functions like a forensic investigator of space, determining whether a planet could harbor water, organic compounds, or even oxygen. This breakthrough extends our scientific understanding far beyond what was achieved with the Hubble telescope. While Hubble's discoveries were remarkable, the Webb telescope represents a quantum leap in space exploration, enabling us to dive deeper into the mysteries of the cosmos. One particularly intriguing object in this vast universe is Proxima B, a planet that has captured the attention of scientists since its discovery in 2016. Situated only 4.22 light-years from Earth, Proxima B is in our immediate cosmic neighborhood, a proximity that is crucial in the grand scale of a universe stretching 93 billion light-years. To put it simply, finding a planet so close to Earth with such potential for scientific research is like stumbling upon a rare gem in a mountain of diamonds. What makes Proxima B so captivating is not just its distance from Earth, but the tantalizing possibility that it might be Earth 2.0. Proxima B resides in the habitable zone of its parent star, where the temperature is neither too hot nor too cold, making it an ideal candidate for liquid water to exist. Picture rivers, lakes, and oceans teeming with potential life. However, before we get too excited about a vacation on this distant world, there are some curious aspects to consider. For example, one day on Proxima B lasts an incredible 11 Earth days. Imagine sunrises that seem to stretch for eternity and sunsets that create golden hours that photographers dream about. While this might sound picturesque, it has significant implications for its climate and habitability. How would life on Proxima B adapt to such long periods of light and darkness? Would humans need to adjust their eating and sleeping habits to match the planet's unique daylight cycles? The rhythms of life as we know them would be both familiar and strange, posing a riddle about what makes a planet truly habitable. With this in mind, you may wonder how we could possibly gather reliable data about a planet we've never set foot on. The answer lies in the James Webb Space Telescope. More than just a telescope, it acts as a multifaceted space laboratory equipped with cutting-edge tools to analyze distant exoplanets in great detail. Utilizing advanced spectrographs, the Webb telescope can break down the light emitted or reflected by distant planets to reveal their atmospheric pressure, composition, and even the presence of vital compounds for life, such as water, organic carbon molecules, and oxygen. The space forensics offering insights into these alien worlds is invaluable. By studying the light they emit, the James Webb Space Telescope is more than an observer. It's a cosmic detective, providing the means to either confirm or disprove our hypotheses about the potential for life on distant planets. Then, just as we thought we had uncovered all the mysteries, an unexpected twist occurred. While using the James Webb Space Telescope, researchers detected an unusual signal emanating from Proxima B, an electromagnetic emission that seemed so structured and complex that it sparked intense discussions. Could this signal be evidence of an advanced civilization? For a brief moment, the entire world held its breath, wondering if this could be the breakthrough confirming that we are not alone in the universe. But just as quickly as it appeared, the signal vanished, leaving behind a trail of unanswered questions. Was it a transient anomaly, or perhaps something far more deliberate, a message or a sign of an advanced extraterrestrial presence? The debate surrounding this signal continues to stir excitement, fueling theories and speculations. The event casts an enigmatic shadow over Proxima B, but also opens up possibilities for future discoveries. Was this just a fluke, or is it part of a much larger cosmic story? Only time will tell. Yet, the search for extraterrestrial life is far from over. Now, a new wave of researchers, including those from Harvard, are expanding our search. They are transforming the James Webb Space Telescope into a cosmic night vision instrument aimed at glowing cities on alien planets, emitting the telltale signs of advanced civilizations. The implications of such a discovery would be staggering, altering our understanding of life in the cosmos. As the search for extraterrestrial life continues, it extends well beyond Proxima B. Advances in space exploration, powered by the James Webb Space Telescope and other observatories, have led to the discovery of more exoplanets that could potentially support life. Instruments like the Webb telescope enable us to study these planets' atmospheres and climates with unparalleled accuracy, looking for signs of life-supporting conditions such as water or organic molecules. The hunt for technosignatures, evidence of advanced technologies on exoplanets, introduces the possibility of detecting artificial constructs such as megastructures or advanced communication systems. This search adds a new dimension to the ongoing investigation of extraterrestrial intelligence. Beyond just finding new forms of life, this search encourages profound questions about our place in the universe. Are we the only ones to have evolved intelligent life? Have other civilizations faced challenges similar to our own? As the search for extraterrestrial life unfolds, humanity stands on the brink of a new era, one where the vast unknown is no longer just a backdrop for our curiosity, but a frontier we are actively exploring. With each discovery, the James Webb Space Telescope and next-generation observatories continue to unravel the cosmic tapestry, revealing clues that challenge our understanding of existence itself. One evening, deep within a high-security research facility, a group of astronomers gathered around a flickering monitor. The room hummed with an almost electric tension. A new transmission had arrived, this time not just from Proxima B, but from an entirely different star system, Tau Ceti, located 12 light-years away. Unlike the fleeting anomaly detected before, this signal was persistent. Its structure was undeniably artificial, patterns of pulses, mathematical sequences, and rhythmic variations that hinted at intelligent design. Days turned into weeks as researchers across the globe attempted to decode its meaning. At first, it seemed like a language, something that could be translated. But as artificial intelligence models and linguistic experts worked tirelessly, they came to a startling conclusion. The message wasn't meant for us. It was a reply. But a reply to what? A chilling realization dawned upon the scientific community. If this was a response, then something, or someone, had sent a message first. The mystery deepened when researchers traced peculiar anomalies in Earth's radio transmissions dating back decades. Somewhere along the way, perhaps even unknowingly, we had sent a signal into the stars, a beacon that had traveled through the void and now, after years of silence, had been answered. The implications were staggering. The question was no longer whether we were alone, but rather, who had been listening. Governments, space agencies, and independent researchers scrambled to interpret the message, but a growing concern loomed. If an intelligent civilization had detected us, what did they now think of us? Were we seen as an emerging species worthy of contact? Or had we revealed our presence to something far beyond our comprehension, something that might not share our sense of curiosity, but rather a hunger for expansion? As humanity grappled with this newfound uncertainty, a second signal was detected, this time much closer. It came from within our own solar system. Near the orbit of Neptune, deep in the Kuiper Belt, an unidentified object had begun emitting an energy signature eerily similar to the message from Tau Ceti. It pulsed in perfect synchronization, as if relaying information from the distant stars back to our own cosmic backyard. Panic and excitement swept across the world. Was this an ancient artifact left behind by an unknown intelligence? A probe? A warning? Or, perhaps, the first emissary of an interstellar civilization? The world held its breath as a hastily assembled mission, codenamed Project Ether, was launched toward the object. As the spacecraft approached, its cameras captured the first images of the enigmatic structure. Unlike any asteroid or natural celestial body, it bore the unmistakable signs of engineering: smooth, angular surfaces, patterns etched into its metallic shell, and an eerie, pulsating glow emanating from within. Then, as if responding to our presence, the object changed. Its energy signature intensified. And then, it sent another message. This time, in our own language. It simply read. The message sent shockwaves through the scientific community and governments worldwide. Every major space agency, intelligence service, and research institution scrambled to decipher its implications. Who had been waiting? For how long? And most importantly, for what? The world watched as Project Ether's spacecraft, Aurora 1, drifted closer to the unidentified object near Neptune. On board, an array of sensors, cameras, and AI systems worked tirelessly to analyze the structure. The object, now designated Artifact X, stood silent after transmitting its cryptic message. Then, something extraordinary happened. As Aurora 1 entered a close orbit around Artifact X, the ship's instruments detected a sudden gravitational anomaly. Space around the object warped ever so slightly, as if reality itself was bending in its presence. The craft's onboard AI, Senex, processed the anomaly and immediately flagged it as non-natural. Something was manipulating the very fabric of spacetime. But before scientists could react, the artifact pulsed again. A sequence of geometric shapes and prime numbers flashed across Aurora 1's communication screens, undeniable proof of intelligent design. Then, for the first time, the artifact opened. A seamless panel on its surface folded away, revealing a dark void within. At first, it appeared empty, but as the spacecraft's high-resolution cameras adjusted, a structure emerged, a bridge, a pathway leading inside. The world collectively held its breath. Aurora 1's AI immediately transmitted an inquiry back to Mission Control. Do we proceed? The debate that followed was intense. Was this an invitation or a trap? What if stepping inside triggered an irreversible event? Some urged caution, while others argued that this was humanity's greatest moment of discovery, an opportunity we could not ignore. After hours of deliberation, the decision was made. A remote-controlled probe, Pathfinder 9, was dispatched from Aurora 1. As it cautiously approached the open gateway, telemetry data streamed back in real time. The probe's sensors scanned every inch of the entrance. Then, as Pathfinder 9 crossed the threshold, it vanished. Not destroyed. Not broken apart. Simply gone. A wave of shock rippled through Mission Control. Every instrument aboard Aurora 1 tried to make sense of what had happened, but no signal, no trace of the probe remained. It was as if Pathfinder 9 had ceased to exist. Just as panic began to set in, Aurora 1 received another transmission, but not from Earth. It came from inside the artifact. A distorted, fragmented signal, Pathfinder 9's transmission. Seeing impossible structures, vast, moving, static. Then, not alone. The feed cut out. And then, one final chilling message came through. Send them. This time, it wasn't from the probe.